Hey everyone, and welcome back. Today, we've got a fantastic software detective story for you. It's a real head-scratcher about a time when a textbook perfect upgrade went silently and just mysteriously wrong.
I mean, think about it. It's a scary thought for any developer out there. You've just rolled out a major update, everything looks great, all the lights are green, you're feeling good. But what if, deep down, something is quietly breaking? What if that perfect update wasn't so perfect after all?
So our story begins, as so many of these do, with what looked like a completely flawless upgrade. I mean, this was a routine, but really critical, project.
The mission was to migrate a core data ingestion service from Scala 2.13 all the way to Scala 3. Now, you got to understand, this wasn't some minor background utility. This service was the beating heart of the system. So performance wasn't just a nice to have, it was absolutely critical. There was literally no room for error. And the team, they did everything by the book. Check, check, check. They updated the dependencies, got the whole thing to compile on the new version, and most importantly, it passed every single test they could throw at it. The rollout to their testing environment, it was perfect.
All the dashboards were just a sea of green. Infrastructure metrics, JVM metrics, application metrics, you name it, it looked healthy. So the team started the staged rollout to production, kept a close eye on it, and it seemed like the job was done. Total success. Or so it seemed.
But then, hours later, things started to get, well, weird. And this, my friends, brings us to the real mystery, the phantom slowdown. What's so insidious here is how this whole problem just crept in. For the first 5, maybe 6 hours after deployment, everything was totally fine. Then, a subtle little alert pops up. The Kafka lag was increasing. The service was starting to fall behind.
And we're not talking about a small dip here. The processing rate for each instance had dropped off a cliff. To handle the same amount of data, they suddenly needed way more instances of the service. It was becoming inefficient and fast.
So the first thought is the usual culprit, right? A sudden spike in data. It happens all the time. But when they checked, the incoming data load was actually pretty modest. This time, something was different. Something was fundamentally wrong with the service itself.
The team made the call to roll back the upgrade, and, like magic, performance snapped right back to normal. This was it, the confirmation they needed. The culprit was the new Scala 3 version. But the why, that was still a complete mystery.
With the what identified but not the why, the real hunt for clues began. Time to put on the detective hats.
They started with the most logical suspects. I mean, it had to be one of the dependencies they'd updated, right? Maybe the serialization library, or the database SDK, or, hey, even the base Docker image. They had a solid list to investigate. But this is where the frustration really sets in. They painstakingly reverted each dependency one by one and retested. The result? Nothing. No change at all. Performance was still in the tank. They were hitting a dead end, and the mystery was only getting deeper.
So, with all the obvious avenues exhausted, it was time to change tactics and dig way deeper. And this is where they found the completely unexpected culprit.
The team decided to bring out the heavy machinery, a CPU profiler. This kind of tool lets you see exactly where a program is spending its time, right down to the individual function calls. They were about to get a picture of the service's inner life.
And the picture it painted was shocking. The CPU profile on Scala 3 looked wildly different from the old version. On Scala 2.13, it was business as usual. But on Scala 3, the JVM's just-in-time compiler, that's the part that optimizes code as it runs, was going crazy, just dominating the CPU time.
Looking at the detailed breakdown, which is called a flame graph, one specific call stood out like a sore thumb. It was this long, expensive operation coming from a library they didn't even realize was being used so heavily.
And here it is. This is the smoking gun. A small library called QuickLens had gone from using a barely noticeable 0.5% of CPU time on Scala 2.13 to consuming nearly half of the total CPU time on Scala 3. 50%! That's just a monster hiding in plain sight.
So, it turned out there was a subtle bug in that library. Its method of chaining operations together became incredibly inefficient when compiled with Scala 3. And this also explained why the JIT compiler was working so hard. It was desperately trying and failing to optimize this terribly inefficient code.
And this brings us to the final, powerful lesson learned from this entire ordeal.
Your code will test you.
You know what's amazing? After all that intense investigation, the fix itself was incredibly simple. Once they knew the culprit was QuickLens, a quick search revealed the bug had actually been fixed in a newer version. They updated the library, and just like that, performance was completely restored.
So the core lesson here is that libraries using metaprogramming, which is basically just code that writes or manipulates other code, can have wildly different performance characteristics between major language versions. A seamless compilation doesn't guarantee seamless performance.
And this all boils down to one fantastic piece of advice. Know your hotspots and benchmark them. Otherwise, your code will benchmark you, revealing bottlenecks in places you didn't even know existed. In other words, don't just assume performance will be the same.
It's just a powerful reminder that even when every test passes and every single metric looks green, silent performance regressions can be lurking right beneath the surface. So I'll leave you with this to think about. What silent bottlenecks might be hiding in your next perfect update?